Hey everyone, welcome to another deep dive, and this time we're going to be tackling the always important topic of reliability in Azure applications.
Oh, reliability. That's always a hot topic.
Isn't it? I
Well,
mean, nobody likes it when their apps crash or their websites are down. It's just a bad experience all around.
absolutely. And that's why it's so important to bake reliability into the design of your Azure applications from the get-go.
Totally. And to help guide us, our listener has provided a really great selection of resources. We've got some Microsoft Learn articles in the mix, and of course, that Azure Well-Architected Framework PDF, which is always a goldmine of information.
Yeah, that well-architected framework, it really lays a solid foundation for thinking about reliability in a holistic way.
Right. So we're going to be pulling key takeaways from all these resources, bringing you the most important insights without getting bogged down in all the details. So if you're ready to unlock the secrets of building rock-solid applications on Azure, stick with us.
Sounds good.
So to kick things off, let's start with the basics. What exactly is reliability when we're talking about Azure applications?
Well, the Azure Well-Architected Framework gives us a really clear definition. And they say that reliability is all about making sure your applications consistently meet the commitments you've made to your customers.
Okay, so it's about keeping those promises you make, like your app will be up and running when they need it.
Yeah.
Yeah.
Just like, if you promise to meet a friend for coffee, show up. Right. It's about being dependable.
Right. You don't want to leave your users hanging. So it's more than just preventing those failures. It's about being able to bounce back quickly when they do happen and making sure that your app can handle growth without like breaking a sweat.
You got it. And looking at all these sources you sent over, it seems like the core components of reliability really boil down to availability, recovery, and scalability. Those seem to be the big three.
Interesting. So those are the pillars of reliability.
Yeah. Like, if you were building a house, you'd need a strong foundation. Well, availability, recovery, and scalability, that's your foundation for reliability.
Okay, so let's unpack those a bit. Availability, I mean, that's pretty straightforward, right? We want our app to be accessible whenever users need it.
Yeah, that's the baseline, right? But then you've got recovery, which is all about how quickly you can get your app back up and running if something does go wrong, because things will go wrong, let's be
Of
honest.
course, no system is perfect. So recovery is about minimizing that downtime.
Got it. And then scalability, that's about making sure your application can handle growth, like traffic spikes or increased data volume, like, those holiday shopping sprees that can bring websites to their knees.
Exactly. Scalability is a key for making sure your app can grow with your business without sacrificing reliability. And that brings us to another important strategy, redundancy. It's one of the cornerstones of building resilient applications.
Redundancy. Okay, so like having backups. Yeah, think of it as having a spare tire in your car. If you get a flat, you're not stranded.
That's a good analogy.
Yeah.
So in the context of Azure, how do we build in redundancy?
Well, a key part of that is replicating components and data across different availability zones and regions.
Okay, availability zones. So those are like those separate data centers within a specific Azure region, right?
Right. And regions are like, those are like separate geographic areas. So if one entire region goes down, you've still got your application running in another region. It's like having a backup generator for your house in case the power goes out.
Okay, so it's about not putting all our eggs in one basket, spreading things out to minimize the impact of any single failure.
Got it. Now, while we're talking about preventing those failures, can you tell me more about this failure mode analysis, or FMA? What exactly is that?
Failure mode analysis. Well, it's like a pre-mortem for your application.
A pre-mortem, what do you mean? Well, instead of waiting for things to break and then trying to figure out what went wrong, you're proactively trying to identify potential points of failure before they happen.
I like that. It's like being a detective, but for your application, looking for clues and weak spots before the crime happens.
Exactly. And one of the articles you sent actually had a really good example. They talked about an e-commerce website built using Azure App Service, Azure SQL Database, and Azure Front Door. And they walked through a hypothetical scenario where, they tried to think of everything that could possibly go wrong with each component.
So they were basically playing what if, right? What if the app service goes down? What if the database gets corrupted? What if the front door stops routing traffic?
Exactly. And by going through this exercise, you can actually start to estimate the impact of potential failures and come up with ways to either prevent those failures entirely or, at least minimize their impact if they do occur.
It sounds like a really valuable exercise,
Yeah.
especially for mission-critical applications where Downtime just isn't an option.
Right. And once you've identified those potential weak spots, you can start to think about how to mitigate those risks. And that's where defining your reliability targets comes in.
Reliability targets. So are we talking about setting specific goals for how reliable we want our application to be?
Yeah, that's it. We're talking about those measurable objectives that give you a clear roadmap for achieving the level of reliability you need. And in these articles, we see those familiar acronyms SLOs, SLIs, SLAs, and of course, RTO and RPO.
Okay, a lot of acronyms. So SLOs, those are those service level objectives. Those
Yeah.
are like those big picture goals, right? Like,
Right.
we want 99.9% uptime.
Yeah, exactly. The SLO is what you're aiming for. It's your target. And the SLI, the service level indicator, is how you actually measure your progress toward that goal. So if your SLO is uptime, your SLI might be something like, the percentage of successful requests that your application handles.
Okay, so it's what you're measuring and how you're measuring it. And then the SLA, the service level agreement, that's more of a formal contract that outlines, what happens if you don't meet your SLOs. That's where the legal and business side of things come in.
Exactly. And then you've got RTO and RPO. RTO is all about, how quickly you can recover after a failure, how much downtime can you tolerate, and RPO is about how much data loss you can stomach. Can you afford to lose, 5 minutes worth of data, or do you need to keep everything up to the second?
Right, so it's about minimizing both downtime and data loss. It's a balancing act. And one of the articles had a really interesting scenario using Azure Front Door, container apps, and SQL managed instance. And they actually walked through how to calculate what they called composite SLOs for a multi-component application.
Oh, yeah, that was a good one.
They really showed how to factor in, potential downtime from deployments themselves,
Well.
which I thought was interesting. They weren't just assuming everything would go perfectly, right? Because deployments can go wrong too. It's about being realistic and understanding that even with the best planning, things can happen.
Totally. And that brings us to another crucial aspect of reliability, disaster recovery.
Okay, disaster recovery.
Yeah.
That's about planning for the worst case scenario, right? Like, what if a meteor strikes our data center?
Well, maybe not a meteor, but, something catastrophic,
Yeah.
right? Like a major outage, a natural disaster, a cyber attack.
Right. So what does a good disaster recovery plan look like?
Well, it involves defining those clear failover procedures, redirecting traffic to a backup system if your primary system goes down. And then you've got to have those failback procedures for smoothly bringing your primary system back online once it's fixed. It's like having an escape route planned out in case of a fire.
I like that analogy.
Mhm.
You don't want to be figuring out how to get out when the smoke alarm is going off.
Yeah.
So what are some key things to keep in mind when designing a disaster recovery plan?
Well, one of the articles really stressed the importance of regular disaster recovery drills. They might seem tedious, but they're crucial for ensuring that your plan is up to date and everyone knows what to do when that proverbial fire alarm goes off.
Okay, drills, got it. Anything else?
Yeah, automation. Wherever possible, try to automate those recovery processes to minimize downtime and, reduce the chance of human error.
Makes sense. So we're being proactive with failure mode analysis. We're building in redundancy. We've got our disaster recovery plan in place. What else can we do to really test the reliability of our application?
Well, there's reliability testing.
Reliability testing. Okay. That sounds pretty self-explanatory, but what does it actually involve?
It's all about putting your application through its paces to uncover any hidden weaknesses and make sure it can handle real-world scenarios.
Okay, so we're talking about different types of tests.
Exactly. There are a few different approaches, like fault injection, where you intentionally introduce errors into your system to see how it responds.
Interesting. So you're basically trying to break things on purpose to see how they break.
In a controlled way, yes. It's like a stress test for your application.
Huh?
And then there's chaos engineering.
Chaos engineering. Okay, that sounds kind of intense.
It can be. It's about deliberately disrupting different parts of your system to test its resilience and identify those unexpected failure points. You're basically giving your application a controlled dose of chaos to see how it handles the pressure.
Okay, I'm starting to see why they call it chaos engineering. And what about load testing? Isn't that important for reliability too?
Oh, absolutely. Load testing is essential for understanding how your application performs under pressure. Like by simulating high traffic volumes, you can identify any bottlenecks that might impact reliability.
Right, you want to make sure your app can handle those Black Friday traffic spikes without crashing.
Exactly. And once you've tested your application's resilience, you need to make sure you're monitoring it continuously to catch any issues early on.
Monitor. Okay, so like having a dashboard that shows us how our application is performing in real time.
Exactly. Continuous monitoring is crucial for keeping an eye on your application's vital signs and detecting those issues before they snowball into major problems. And, these articles recommend using Azure services like Azure Monitor and Application Insights, which are really powerful for collecting all sorts of data.
Right. And one of the articles had a great tip about not just collecting data for the sake of it, but actually using that data to create actionable alerts. Like if a certain metric crosses a threshold, trigger an alert so you can take action before it impacts users.
Exactly. Don't just watch the dashboard, use the data to drive action. And speaking of taking action, let's talk about those advanced concepts we mentioned earlier. Self-healing and self-preservation.
Okay, these sound like they take reliability to a whole new level.
They do. Self-healing is all about building those automated responses to failures so that your application can recover without any human intervention.
Wow, so it's like giving your application the ability to heal itself.
You got it. And self-preservation is more about proactively protecting your application from potential threats. It's like giving your application a shield.
Okay, so self-healing is about fixing problems after they happen, and self-preservation is about preventing problems in the first place.
Got it. Are there any real-world examples of how to implement these concepts?
Yeah, the articles mention patterns like circuit breakers, which prevent cascading failures by stopping requests to a failing service, and retry logic, which automatically retries failed operations. And there's also a great example of a real-world application using the Azure event-based cloud automation reference architecture.
Interesting. So those are some concrete ways to build self-healing and self-preservation into our applications. Now, we've talked a lot about the software side of things, but how does Azure's infrastructure itself contribute to reliability? Oh, that's a great question. Azure's global infrastructure plays a massive role. We've got those availability zones, which are like those backup data centers within a specific region.
Mm.
And then we've got entire regions, which are like backups in completely different geographic locations.
So you can choose different levels of redundancy based on your specific needs and risk tolerance.
Exactly. You can have zonal deployments for protection within a region, zone redundant deployments for even greater resilience within a region, and then multi-region deployments for, the ultimate protection against widespread outages.
It's like having multiple layers of insurance for your application.
Right. And now it's important to acknowledge that achieving those high levels of reliability, it often involves trade-offs. There's no such thing as a free lunch.
Trade-offs, okay. Like what?
Well, mainly cost and complexity.
Yeah.
Building in all that redundancy, implementing those sophisticated self-healing mechanisms, it all adds up. And, as you add more components and layers of protection, the architecture can become more complex to manage.
Right. So it's a balancing act. How do we determine how much reliability is enough for a particular application?
Well, that's the million-dollar question, isn't it? The answer really depends on your unique business needs, your risk tolerance, and, the potential impact of an outage.
Okay, I'm feeling like we've covered a lot of ground here. We've gone from the very definition of reliability all the way to these advanced concepts like self-healing and self-preservation.
Yeah, we've definitely unpacked a lot.
But now it's time to roll up our sleeves and get into the nitty-gritty of how all these principles actually translate into real-world configurations on Azure.
Let's do it. Welcome back. Ready to get into the specifics?
Absolutely. Let's dive into how those reliability principles we've been talking about actually play out with real Azure services.
You got it. So let's start with a service I'm sure you're already familiar with, Azure App Service. Super popular for hosting web apps, right?
Oh, yeah. App Service is like the bread and butter for a lot of web apps out there.
Oh.
So what are some of the key things to keep in mind for reliability when we're working with App Service?
Well, one thing that really jumped out at me from these articles was the idea of using separate app service plans for your production and test environments, to keep things isolated.
Yeah, that makes a lot of sense. You don't want some weird bug you're testing to take down your live application.
Exactly. Got to keep those environments separate. Another good tip is, deploying to a staging slot first before you swap it into production.
Ah, staging slots, like having a dress rehearsal before the big opening night.
Yeah.
You can catch those issues before they impact real users.
Right. And speaking of preventing bad updates, one of the sources talked about having a deployment slot specifically for your last known good deployment, just in case.
It's like a safety net. If something goes wrong, you can quickly roll back to the previous working version.
Exactly. And one thing that seems to be super crucial across all these services is logging. Got to have good logs.
Oh yeah, logging is essential. It's like having a black box recorder for your application.
Right. Helps you monitor your application's health, diagnose issues, see how users are interacting with your app. Super valuable.
So what specific logging recommendations did you find helpful?
Well, the articles suggest enabling both application logging and web server logging, and storing those logs in Azure Blob Storage. Easy to analyze, lots of space.
Blog storage is great for that.
Yeah.
And there was even a tip about creating a separate storage account just for logs, right?
Yeah, that's a good one. Because if you're storing your logs in the same storage account as your application data, those logging operations could actually impact the performance of your app, especially during, those peak traffic times.
Right. You don't want your login to slow things down when you need it most.
Exactly. So that's app service. Now let's shift gears and talk about another key service for reliability, Azure Load Balancer.
Load balancers. They're all about distributing traffic across multiple servers, right? So if one server goes down, the others can keep things running.
Precisely. And when it comes to Azure Load Balancer, the sources strongly recommend using the standard CU for production workloads.
The standard CU. Okay.
Yeah.
Is that because it offers more reliability features compared to the basic CU?
You got it. The standard load balancer, it comes with things like zone redundancy and support for availability zones, which, as we talked about earlier, are super important for those resilient applications.
Right, those availability zones, like having backup data centers within a region.
Exactly. So standard load balancer, definitely worth considering for those mission-critical apps. Now, what about Azure Event Hubs? Ever worked with that?
Event hubs, yeah. It's designed for streaming data.
Right.
Like handling those real-time events from IoT devices.
Yeah.
Or processing, high-volume telemetry data.
Right. And even though Event Hubs is built for scale, there are still some things to keep in mind for reliability. It's not just a set it and forget it kind of service.
Okay, so what are some of the gotchas we need to be aware of with event hubs?
Well, one thing the sources mentioned was the importance of handling duplicate messages.
Duplicate messages. Why is that a concern?
Well, you see, in a distributed system like Event Hubs, it's possible for the same message to get delivered multiple times. And if your application isn't prepared for that, it could end up processing the same event over and over again, which could lead to inconsistencies, even errors.
Ah, I see. So you need to make sure your application can detect and discard those duplicates.
Exactly. And then there's exception handling. Got to make sure you're handling those exceptions properly, especially when you're dealing with, batch processing scenarios.
Right, because if an error occurs during batch processing, you don't want it to bring the whole pipeline down.
Exactly. And one more thing about Event Hubs, don't forget about disaster recovery. The sources recommend using Event Hub's Geo-Disaster Recovery feature.
Right, so that if your primary Event Hub's namespace goes down, you can automatically fail over to a secondary namespace in another region. It's like having a backup plan for your data streams.
You got it. Now, how about Azure Storage? You must use that all the time.
Oh, yeah. Azure Storage is foundational. Blobs, queues, tables.
Yeah.
It's where we store pretty much everything.
Mm.
So what are some of the best practices for reliability when it comes to Azure Storage?
Well, for that critical data, the articles recommend using Read Access Geo-Redundant Storage, or RAGRS, or Read Access Geo-Zone Redundant Storage, RAGZRS. Those are a bit of a mouthful.
Yeah, those are some serious acronyms.
But basically, these replication options, they ensure that your data is copied to a secondary region, so you're protected against those regional outages.
Right, so if one region goes down, you still have access to your data in another region. It's like having a backup copy of your most important files.
Exactly. And for queue storage specifically, there's a clever little tip. They recommend creating a backup queue in a different region.
A backup queue? Interesting. Why would you do that?
Well, imagine your primary storage account becomes unavailable for some reason. With that backup queue in place, your application can actually continue processing new requests using that backup queue. So, it minimizes disruptions to your service.
Ah, clever. It's all about keeping things running smoothly, even when there are hiccups. Now, let's talk about Azure SQL Database. That's a popular choice for relational data, especially for those apps that need, transactional consistency.
Right. And for production workloads, the sources recommend going with either the standard or premium tier.
Okay, standard or premium? What are the benefits of those tiers from a reliability perspective?
Well, they offer a longer point-in-time restore period. So, if you need to recover from accidental data loss or corruption, you've got more flexibility.
Right, you can go further back in time if you need to. like a time machine for your database.
Exactly. And another important thing is enabling SQL database auditing, to keep track of who did what and when.
Ah, auditing. It's like having a security camera for your database.
Right. Helps you detect those security threats, track down human errors, make sure you're complying with those regulatory requirements.
And of course, we can't forget about backups. They're essential for any database.
Absolutely. The sources really emphasize the importance of a robust backup and recovery strategy for a SQL database.
So regular backups, geo-replication, point-in-time restore capabilities. It's all about having multiple layers of protection.
You got it. Like a good security system. Multiple layers of defense.
Okay, now let's move on to Azure Traffic Manager. It plays a key role in, routing traffic effectively.
Right. Traffic Manager is like the air traffic controller for our Azure infrastructure, making sure those requests get to the right destination.
Exactly. And the articles had some interesting insights about using Traffic Manager effectively. One recommendation was to perform manual failback after a failover, instead of relying on automatic failback.
Interesting. Why would you prefer manual failback in some cases? Well, sometimes, automatic failback can cause problems if the original issue hasn't been fully resolved. Manual failback gives you more control, so you can double check that everything is really working before you switch back.
Makes sense. Any other Traffic Manager tips that you found helpful?
Yeah, they also recommended creating a custom health probe endpoint. Something that monitors the overall health of your application, not just the front end.
Right. So it's not just about checking if the website is up, but also making sure the back-end services, the databases, everything is healthy.
Exactly. By having that more comprehensive view, Traffic Manager can make smarter decisions about routing traffic. It's like having a traffic cop who can see the entire road, not just the intersection.
I like that analogy. So we've covered app service, load balancer, event hubs, storage, SQL database, and Traffic Manager. I'm sensing a theme here.
What's that?
Azure has a lot of tools and services to help us build those reliable applications. But it's not just about the technology, right?
Oh, you're absolutely right. The human factor is huge.
Like teamwork, communication, having clear roles and responsibility.
Exactly. The articles emphasize the importance of all that. Reliability isn't just about code, it's about people, too.
Okay, so let's bring it back to those reliability targets we talked about earlier, those SLOs, SLIs, all that good stuff. How do we actually define those targets? Where do we even start?
Well, it all starts with understanding your business requirements. What can your business actually tolerate?
Right, like what level of downtime is acceptable? How much data loss can we handle? What's the financial impact of an outage? Those are the big questions.
Exactly. Once you have a good grasp on those factors, you can start setting those reliability targets. And those targets, they got to be both ambitious and achievable, right?
Ambitious but achievable. I like that.
Yeah.
Shoot for the stars, but keep your feet on the ground.
Right. And one of the articles had a helpful example using a hypothetical application. They used Azure Front Door, container apps, and SQL Managed Instance. And they showed how to calculate a composite SLO, taking into account the individual SLOs of each component.
Ah, that's interesting. So you're basically taking a holistic view, looking at the reliability of the entire system, not just the individual pieces.
Exactly. And they also factored in things like, code defects, configuration errors, potential downtime from deployments. It was a really comprehensive approach.
Right, because those things can happen.
Yeah.
It's about being realistic and understanding that even the best teams make mistakes sometimes. Now, speaking of planning for the unexpected, let's talk more about disaster recovery planning. How do we create a solid plan that we can actually rely on?
Well, the Sweeses gave a lot of great guidance on that. And they said it starts with, identifying your critical flows, like which parts of your application are absolutely essential, the must-haves.
Right, the things that need to be up and running no matter what.
Yep.
And then you do that failure mode analysis to figure out, what could go wrong and what impact that would have.
Exactly. Once you have a good understanding of those vulnerabilities, then you can start building out your DR plan. And that plan, it should include those detailed procedures for failover and failback, step-by-step instructions for what to do if disaster strikes.
Right. And automation is key here, right?
Absolutely. Automate as much as you can to minimize downtime and human error. And don't forget those disaster recovery drills. They might seem like a pain, but they're super important for making sure everyone knows their role and the plan actually works.
Drills are like fire drills for your application.
Yeah.
Better to practice now than when the building is actually on fire.
Exactly. And remember, your DR plan, it's not a one and done kind of thing. It needs to evolve as your application changes and grows.
Okay, so DR plan in place. Check.
Hmm.
Now let's revisit those advanced reliability concepts, self-healing and self-preservation. How do we actually put those into practice?
Well, the articles highlighted a bunch of different patterns that can help you build those super resilient applications. Things like the circuit breaker pattern, the retry pattern, the throttling pattern.
Those sound intriguing. Can you give me a quick rundown of how those work?
Yeah, so the circuit breaker pattern, it's like, it prevents those cascading failures by basically stopping requests to a failing service. It's like a safety switch that trips when things start to go wrong. And then the retry pattern, it automatically retries failed operations a certain number of times before giving up. Sometimes those transient errors just need a second try. And then the throttling pattern, it limits the rate of requests to prevent your application from getting overwhelmed. It's like a bouncer at a nightclub who only lets a certain number of people in at a time.
Okay, those are some great analogies, like having built-in shock absorbers for your application.
Yeah.
And one thing I noticed in the articles was a focus on background jobs. It's easy to overlook those when we're thinking about reliability, but they're often critical to how an application works.
Oh, absolutely. Background jobs, those are the unsung heroes of a lot of applications. Sending emails, processing orders, generating reports, all that happens in the background.
So what are some of the key things to think about for reliability when we're working with background jobs?
Well, the sources recommended thinking carefully about, triggers, resource conflicts, and resilience.
Triggers, resource conflicts, resilience. Can you elaborate on those a bit?
Yeah, so triggers, they determine when a background job is executed. You got to make sure those are reliable and don't miss any events. And then resource conflicts can happen when, multiple background jobs are competing for the same resources, could lead to deadlocks or performance issues. And then resilience, that's the ability of background job to handle failures gracefully, to keep processing even if errors occur.
Right, because we don't want those background tasks to just die silently if something goes wrong.
Yeah.
And Azure provides a bunch of services for handling those background jobs, right?
Oh, yeah. There's web jobs, Azure Functions, Azure Batch. Plenty of options to choose from, depending on your needs. And now, let's wrap things up with a discussion of those trade-offs involved in pursuing reliability. We can't just blindly chase reliability without considering the costs.
Right, it's all about balance, isn't it?
Exactly. Like we mentioned earlier, reliability comes at a cost, both in terms of, money and complexity.
So how do we find that sweet spot between reliability and other important factors like security, performance, and, keeping things manageable?
Well, the articles provided some good food for thought on that. For example, adding redundancy can boost your reliability, but it can also make your infrastructure more complex to manage. Implementing those super strict security measures, that can enhance reliability too, but it might slow things down a bit.
It's a balancing act for sure. Too much emphasis on one factor can throw everything else out of whack.
Exactly. And that's what makes building reliable applications such an interesting challenge. It's not a one-size-fits-all solution. You got to weigh those different factors and make those smart decisions based on your specific circumstances.
Absolutely. But the good news is, with the right approach and all the tools and services available on Azure, we can definitely create applications that are both reliable and performant.
Absolutely. Now, for the final act of our reliability deep dive, let's zoom out and explore the why. Why should we even care about all this?
Excellent question. Stay tuned, folks. We'll be back after a short break to tackle the big why of reliability. Welcome back, everyone, for the final part of our deep dive into reliability in Azure applications.
We've covered a lot of ground, haven't we?
We have, from those basic design principles all the way to those nitty-gritty details of specific Azure services. But now, I think it's time to tackle the big question.
The why.
Exactly. Why should anyone building applications on Azure care so much about reliability?
Well, in today's world, everything is online. Businesses live and die by their online presence.
Right. Customers expect those applications to be available 204/7, 365.
Exactly. Any downtime, even for a few minutes, can have a huge impact.
Yeah. I remember a while back, there's that big outage that took down like a major social media platform.
Oh, yeah, that was a mess.
And businesses that relied on that platform, they lost a ton of money.
Absolutely. And beyond that financial hit, there's the damage to your reputation.
Right. Customers get frustrated. They lose trust.
Yeah.
And they might even switch to a competitor.
Exactly. So investing in reliability, it's really about investing in the long-term success of your business.
You're protecting your revenue, your brand, your customer relationships.
All of that. And these sources we've been looking at, they really highlight how critical reliability is. They offer that practical guidance, real-world examples, insights from those experts who've been there and done that.
So for someone listening to this, what are some concrete steps they can take right now to make their Azure applications more reliable?
Well, start by taking a hard look at your existing application.
Put on your detective hat.
Exactly. Do that failure mode analysis we talked about.
Huh.
Identify those potential points of failure. Don't just assume everything's fine. And then, set those reliability targets.
Like those SLOs, SLIs.
Exactly. Figure out what level of uptime you need, how quickly you need to recover from a disaster.
And then start putting those strategies in place. Redundancy, scalability, self-healing mechanisms, disaster recovery planning, all of that.
And remember, reliability is an ongoing process. It's not a one-time fix.
It's a journey, not a destination.
Exactly. You're constantly monitoring, testing, improving.
So was there anything that really surprised you or stood out to you as you were going through all these resources?
One thing that really struck me was how interconnected all the different aspects of reliability are. It's not just about redundancy or disaster recovery and isolation. It's about all those pieces working together.
It's like a puzzle,
Yeah.
right? All the pieces have to fit together.
Exactly. And another thing that kind of hit me was the importance of keeping things simple.
Oh, interesting.
Yeah, sometimes complexity can actually be the enemy of reliability. The more complex a system is, the more things there are that can go wrong.
That makes a lot of sense. Simplicity is elegance.
Right. So as you're building those reliable applications, keep that in mind. Sometimes the simpler solution is the most reliable solution.
Great advice.
Yeah.
So for our listeners who want to learn more and keep digging into this topic, where should they go?
Well, the Azure Well-Architected Framework website is a great resource. And of course, there's tons of information on Microsoft Learn.
Definitely. Microsoft Learn is a goldmine of knowledge.
Yeah.
And don't be afraid to reach out to the Azure community. There are so many experts out there who are willing to help.
Absolutely. It's a great community. Always happy to help.
And before we wrap up, I have one final thought to leave everyone with. We've talked a lot about building reliability into our applications. But what about building reliability into ourselves?
I like that.
How can we be more resilient in the face of challenges? How can we bounce back from setbacks and keep learning and growing? It's something to think about.
It is. And on that note, I think it's time to wrap up this deep dive.
Thanks for joining us, everyone. We hope you learned a lot about building reliable applications on Azure.
Until next time.